Hello everyone, let me introduce you to Data Park, the next generation solution for all of UND's parking problems. My name is Matt Fuca and my teammates are Evan Rommel and Alex Zowie. Are you tired of driving around and around parking lots searching for spots in parking lots that you've bought permits for?
There's no spots anywhere. Unbelievable.
Well, we are too. And just as our friend Evan has said, yes, it is unbelievable. That is why we propose Data Park as a viable, robust solution to UND's parking problems.
There has to be a better way.
And yes, Evan, there is a better way. That is why Data Park is here. So, what is UND's current parking problem? Well, as evidenced by Evan, parking lots on campus are often full when you need a parking spot. And driving through full parking lots in search of a spot can be very time-consuming and frustrating. So, how can UND best accommodate all students, faculty, and guests who need parking spots? Well, they could either add more parking spaces, which costs a lot of money. They could restrict the amount of parking permits there are so that they would limit the amount of people that could park in the parking lots. Or they could do a variety of other things such as hire more parking police, limit the amount of time that you can park in the parking lots, etc., etc. However, these options are either expensive or would be very unpopular among the campus population. Therefore, we introduce to you Data Park, a robust, analytical parking data system that can efficiently reduce costs and determine the most effective method in alleviating UND's parking problems. So why is Data Park the big idea that will help solve UND's parking problems? Well, first off, it will offer a data analysis of the parking lot's usage, including the number of users per lot, the time of day the users are parked in each lot, and the length of time each user is parked in each lot. Furthermore, after successful implementation of this parking system, a phone application can also be developed, and this will provide users with the number of remaining spots in each lot, and it will also be able to ticket parking violators, and will be able to expand to a variety of other uses that will help UND's community. Our plan to successfully implement Data Park into UND's parking system is to bring it through 4 phases. In Phase 1, we'll go through software creation and testing. In Phase 2, we'll install hardware and do the preliminary implementation. In Phase 3, we'll move to full implementation of Data Park into the UND parking system and gather data for analysis and further improvements to UND's parking infrastructure. In Phase 4, we'll move to phone application development and full integration of Data Park software capabilities into the UND Parking Services system. Data Park will function by placing ground vehicle license plate readers at the entrances and exits of each parking lot. Our cost estimate assumes there are approximately 50 parking lots on UND campus that need Data Park services. After gathering, exiting, and entering vehicle information, the data is sent to Data Park databases for further analysis. Here, Data Park will analyze the previous parameters talked about and will output an accurate visual representation of the parking traffic on campus. This will help determine future improvements to UND's parking system. Finally, a phone or web app can be made to show users how many open spots are left on each respective campus parking lot. In addition, UND can use our Data Park services to ticket parking violators, thereby eliminating the need for the parking police. All of these improvements will greatly enhance the parking experience of the UND community. To efficiently accomplish all of these tasks, we'll have a very diverse and talented team. Let's meet the team.
Hi, my name is Matt Fuca. I'm a second year's master's student in mechanical engineering, and I'll be working on the design and implementation and some research of the parking program.
Hello, I'm Evan Rommel. I'm an entrepreneurship major and a computer science minor. I'll be working on some front-end coding and a little bit of the business aspects.
Let's look at some preliminary cost analysis of the two systems. In the first system, the numbers shown are approximate values shown from the data gathered on the internet. Here, according to these values, the total initial cost of the first system is approximately $150,000 to $200,000. The total recurring costs are about $124,000 per year, and there are some additional unaccounted for costs. such as oil changes for the cars, wages for the parking services help desk people, and a variety of other unaccounted for costs. In comparison to Data Park, where the numbers shown here are also approximate values gathered from the internet, the total initial cost of our system is about $541,000, which is considerably more expensive than the current system. However, the total recurring costs here are $0. There are some additional unaccounted for costs, but those are very similar to the current system and therefore can be neglected. And with the implementation of our data park system, a cost savings and money back will be realized in a maximum of 5 years. Some very preliminary tests were done with Data Park, and they yielded great results.
Thanks to Data Park, I can always find a spot when I need.